this session, we're going to be talking about machine learning here at AWS. And I titled this Getting a Head Start with ML here at AWS. So I know everyone saw me speak 2 presentations ago on security, so you might have already gotten this information. But again, just to reiterate some of this information, I'm a senior developer advocate here, essentially an engineer who helps build awareness and adoption. If you do have any questions on any of the material that you see here or the previous presentation, feel free to reach out to me. Twitter is by far the fastest way to get in touch with me, so at Kunal732 is my Twitter handle. Or you can email me, kbatra@amazon.com, or feel free to connect with me on LinkedIn as well, Kunal Batra. It's my name there. So this presentation encompasses a lot of what I truly find I have passion for. You can see some of those examples over here. I made an image classification, an object detection model, another object detection model of common household items. It's just something that I'm passionate for, I have a lot of experience with. So if you have any questions on any of this, feel free to reach out. Okay, so let's get started. The goal we have here at AWS is to put machine learning in the hands of all developers. It doesn't matter if you're an advanced machine learning practitioner, data scientist, or you're an application developer. We want to make sure that regardless of the type of expertise that you have tools that you can use to integrate machine learning into your applications. And we spoke a little bit about this in a previous presentation, but I want to expand more on this in this presentation. So the way we look at machine learning here at AWS, again, is in this stack. So that top level over here, those AI services, these are APIs that open for any developer to use. A lot of these are services that we've created here internally, either for Amazon.com or at AWS, and then we've gone ahead and opened this up as an API for our customers to take advantage of as well. And so Fraud Detector was one of those services when we spoke about. That's something that we opened up as well for all of our customers to use. Now, when we look one level lower into those machine learning services, these are the suite of tools under that SageMaker umbrella that makes it easy to build, train, and deploy your machine learning models. So we're going to be talking about some of those services here as well. And then that last layer over here, this is our machine learning frameworks and infrastructure. These are for advanced machine learning practitioners, data scientists who are really comfortable at that framework level. You see different types of frameworks. We want to make sure that we have each of those optimized to run the best they can on the AWS cloud. We want to give you the ability to either run those through on the AMIs or using containers, have the ability to use GPUs or CPUs for that training if needed. And then also the ability to save costs for making those inferences, right? So you don't have to use heavy lifting GPUs that you use to train your model to also for the inferences as well. We have different types of services for that. So we have elastic inference, and also we have the inferentia chips that you can take advantage of too for those inferences. So one thing to note here is at AWS, we're framework agnostic. We have lots of different frameworks that run here on the AWS cloud. You can actually run them fully managed. So fully managed means under that SageMaker umbrella, we don't have to worry about that infrastructure. You can run them yourself as well. And TensorFlow tends to be one of the most common frameworks here at AWS. So 85% of all TensorFlow workloads actually run on AWS. And the goal we have here, again, is to make sure that each of these frameworks run in the most optimized way possible. So you can see an example of that over here. You see stock TensorFlow has a 65% scaling efficiency when you with 256 GPUs. Now, with an AWS optimized version of that TensorFlow, that you can see that goes up to 90% scaling efficiency with 256 GPUs, and this gives some significant performance improvements in your model training, especially with speed as well. So you have the ability to take advantage of these frameworks either through our AMIs, or you can take advantage of containers and run them on EKS or ECS as well too. Now, moving up under that SageMaker umbrella, this is a really interesting suite of tools that we have over here. Again, it makes it easy to build, train, and deploy your models. And we're going to talk about a couple of the services here. The ones that I find really compelling are autopilot over here. It's our AutoML solution. It helps you understand the best ways to put together a model by us actually using machine learning for uh, that training for that model. So it's interesting. We'll talk about that in a second. Then the other service I want to touch upon here is Ground Truth as well, and we'll showcase some of the other SageMaker services here as well. So the one thing to note over here is when you think of machine learning here, it's important to note that this is not a linear process. This is not a straight line. And there are many more steps to this slide than what's shown over here, but it's not just data prep, model training, model inference. This is a very iterative process, almost like an art. I've heard it being referred to, right? This is something that's complex and it takes years of experience to really get right. So this is where that autopilot feature that I was talking about really comes into play. When you're trying to go from that application developer and try to learn more about machine learning and what are the best ways to get started, I recommend really checking out our autopilot service over here. So just to give a little background and level set everyone over here, there are a couple of different types of machine learning. There are actually 3 popular types. So this slide shows 2. So there's supervised learning, unsupervised learning, and also reinforcement learning. But supervised learning, it requires all of your inputs to be labeled. So for example, in that first slide, I showed a photo of a garage door. And essentially, I created an application that lets you know whether a garage door is open or closed. To build that, needed a bunch of different types of data and have that labeled. Is that garage door open? Is it closed? And then from there, I'm able to see a new photo of a garage door and make an inference based on that. And that's supervised learning. Now, for unsupervised learning, we only need to know the inputs. There's no required output labels there. Unsupervised learning algorithms will take a look at the attributes of those inputs and do things like cluster it based on similarity. And I apologize, it sounds like there's some construction happening in the building. Let me know if there's something you want me to repeat. So now inside of these algorithms, supervised learning and unsupervised learning, there are different types of categories of algorithms here, right? So for supervised learning, you can do classification. So classification essentially means you're trying to choose between different classes. For example, the garage door, is it open or closed? Is something true or false? Is it red, blue, green? Regression is if you're trying to give some number here, some value. So what's the temperature? What's the stock price? And that's regression. Unsupervised learning, you can do things like clustering based on the similarity. You can also do other types of algorithms as well that fall into that unsupervised learning umbrella. And then again, with reinforcement learning, again, you have more of different algorithms that you can choose, right? So there is a lot of algorithms here that you can use, and one might have superior performance than another based on your data set. And with a lot of experience and having a lot of practice with this, you start understanding what those algorithms are and what makes sense to get that improved performance. But in the beginning, that's hard to know, right? And this is where AutoML solutions come really into play. So just again, to reframe this here, the machine learning process in general, this is typically how it looks like. You have some sort of business problem. You're trying to now frame that into a machine learning problem. Is this going to be supervised, unsupervised? If it's supervised, you want to make sure that you're collecting that data, in this case, from different types of sources. You're integrating into one source. You're going to prepare it and clean it, take away any duplicates. From there, you're going to want to analyze it and then start doing feature engineering, right? So we want to see that are we picking the right values in that data that it's appropriate for our model for training it. From there, you're going to go into model training and parameter tuning. It's in one little box here, but this is something that you're going to want to iterate quite a bit on. Then from there, you're going to go into, are you going to evaluate that model? And then you're going to probably iterate this a couple of times until you get performance that you're happy with. From there, you're going to go ahead and deploy it. Once it's actually in production, you're going to notice, and a lot of times this is something I've noticed, using that real life data, you're going to realize, wait, this is not giving the values you want. Let's go ahead and retrain that with some more real life data. So this is definitely an iterative process, and it takes a while to get it perfect. So With Autopilot, one of our AutoML solutions, it takes care of a lot of these solutions. So everything you see here with the star is something that's being automated with Autopilot over here. So if you look at this in a linear format, again, remember, this is not linear, but if you look at this in a linear format, you can see that Autopilot takes care of quite a few of those steps, a lot of the heavy lifting that comes when it comes to training machine learning models. So we have two tools here to do AutoML. One, like I mentioned, is Autopilot. Autopilot's really interesting because it not only gives you that automated machine learning trained model that you can use, but also gives you the insights behind it. It's not a black box. And a lot of times you see with our competitors or other solutions for this that it's a black box where they just give you that model, but you don't know what happened in the background. Why were the decisions made that came to this model? And that's the best part of Autopilot. It has this ability to give you notebooks that you can look at where it tells you, here's the pipeline you used, this is why, this is the insights that got into your data sets, and these are the decisions it's made. So it actually helps you learn as well, just in case you don't want to use Autopilot and you want to just take advantage of other aspects of SageMaker to build your model. Now, another solution that we have here is AutoGluon. AutoGluon is an open source solution. So the differences between these two, Autopilot gives you that insights on what's happening behind the scenes, but this only works for tabular data right now. While AutoGluon, it doesn't give you those insights of what's happening between the scenes, but it works for multiple different data types. And also AutoGluon is it's really accurate. We'll touch upon that in a bit. So you can see an example of Autopilot over here. On the left-hand side, you see the how Autopilot looks like when the console for AWS. On the right-hand side over here, you're taking a look at a window that's called SageMaker Studio. So SageMaker Studio is a single pane of glass that has all the different aspects of training your machine learning model in one place, right? So essentially, this is just like a souped-up Jupyter notebook, and this is where we also play around with Autopilot in as well. So Autopilot, you basically provide this as some sort of tabular data. From there, you specify the column you want to predict on. In that tabular data, Autopilot then will go ahead and create that model, and then it'll go ahead and track that for you. And again, the one key thing is that it will also give you the insights into why it made the decisions it made, as well as giving you insights on your own data set as well. So let's take a look at this. Let me get out of this presentation over here. Here, and then let me showcase one thing. Can everyone see this Excel sheet over here? Don't worry about the values right now if you can't read it or not. Essentially, what this Excel sheet is a lot of simulated data. This is data that we created just to showcase an example here. And this is for people who either accepted a marketing offer or didn't accept a marketing offer. You can see different aspects of features over here, whether like what type of job they have, the education they have, the marital status, how were they contacted, what day of the week, etc. And the last column over here, you see it's labeled Y. This is whether they accepted the marketing offer or not, right? So this is the type of data that Autopilot is great with. Now, when you want to access anything on AWS, you want to go to console.aws.amazon.com. It gives you the ability to see all of our services over here. And in this case, we're going to say SageMaker, right? Just for the sake of time, I've already have everything opened up. And what you're looking at right now is SageMaker Studio. This is what we saw in the presentation as well in that graphic. This is a single pane of glass that has everything you need to know. So basically, when we want to create an Autopilot job over here, we say File, New Experiment, and it gives us this screen, Create Amazon SageMaker Autopilot Experiment. Basically, what we can do is we can just create an example over here. What is this? November, and then from here, we can just tell it where our data is. We have to take that data, the one I just showcased to you in that Excel sheet, and we have to put it in a bucket. And we just have to let it know where that sits. And over here, we just select it. And then it asks us, what is the target attribute that it wants to make predictions on? So we over here, we specify the column is labeled as Y, And so anytime now we get a new piece of data, we wanted to make an inference. Is this going to be yes or no? Are they going to accept that marketing offer or not? We just say, where do we want this data to be stored? Once the model to be stored, once it's done, we say it's the same bucket over here, AIML-data. And then we choose the type of machine learning problem type. Typically, I always advise people to leave this as auto, but you can choose, is this going to be binary classification between two choices, multi-class, obviously more than two, and then regression, is this going to be some sort of continuous value that you want to predict? If you leave it as auto, it'll understand it, and for most of the time, this tends to work pretty well. However, there can be times where multi-class classification and regression can be very similar. If you have a lot of different types of classes that seem numerical, and regression is also looking for numerical values, and it gets confused, in those rare instances, it will let you know, it will ask you which one is this and ask you to specify it, but most of the time it's able to pick that up. But you can also just if you think that'll be an issue, you can go ahead and choose that in this interface. And then the last question here, do you want to run a complete experiment? And this is a really important question. Yes means it'll go ahead and create that model, and you have the ability to deploy that model, and then from there make inferences on it. No means that you just want the insight. You're just asking for, show me what you would do to build a great model based on this data. And then from there, you can just take those learnings and then apply that yourself, or modify that and apply that yourself using SageMaker. So typically in this case, we say yes, and then here's a job that I've done in the past. Let's say describe this AutoML job. Now you can see over here that it's gone through, it's created a bunch of models for us, right? It goes through a set of algorithms, creates a bunch of models for us, and then you can sort this based on accuracy, and then from there you can say, take this best performing model and let's go ahead and deploy that model. And now you can choose a type of infrastructure that you want to deploy that model on. You can give this endpoint a name, and then from there you can say, what pieces of data do you want back when you make inferences? Do you want back the probability, labels, etc.? The predicted label is set by default. So that's Autopilot here. It's a really powerful tool with SageMaker Studio. So let me go back into my presentation. This is Autopilot. The next, we spoke about AutoGluon as well. So AutoGluon, again, this is an open source tool. It doesn't give you that insight of what's happening behind the scenes, but it does give you the ability to create models based on tabular data, text classification, image classification, object detection. Very simplistic to use. You can see over there, in this particular case, just needs 3 lines of code to do that same example of what we just saw with Autopilot. Really powerful stuff. It also puts you in the top spots for Kaggle competition, so it's actually really accurate, I would say. So yeah, definitely take a look at both of those. This is something that piques your interest over here. There's more resources here as well. Well, if you want to take a screenshot, feel free to. I'll send this slide to Ron as well if you're interested. Now, other aspects of SageMaker outside of Autopilot, again, is that SageMaker Studio is what we just saw. It's that single pane of glass that lets you track your experiments and work through everything that you need in one place, which is really powerful. Now, one of the other things I want to talk about here that to me I feel like is essential when it comes for ML practitioners is labeling your data, right? This is something it's a hard problem, and to have an accurate model, you need typically, when we see our customers, large data sets to solve the problems that they're solving. And now every problem is different and requires a different amount of data, but typically this ends to be a pretty difficult problem. So Ground Truth is one of the services that we have here that really helps labeling those large data sets, right? It does a couple of things. It lets you quickly label that training data. It gives you the ability to easily integrate with human labelers. It gives you accurate results, and then it also helps with some pricing issues too, and we'll talk about that as well. So for quickly labeling that data, Ground Truth gives you these pre-built labeling workflows, right? So you can see a portion of them here on this slide. It gives you the ability for your labelers to quickly draw bounding boxes, to classify images, classify text, to do semantic segmentation, so you know what an object is based on that pixel, the pixel level in an image. And if there's something that's not there with ground truth, you can create a custom template as well. And I've seen this used for audio classification as well from our customers. So the next step here is selecting a pool of labelers. We give you 3 different buckets here to select from. You have that public workforce over here for Mechanical Turk. This is a workforce of 500,000 strong. This is great for fast labeling, great for non-sensitive data, for lower price sensitivity. But if you do have sensitive data, then you have a couple of options. You can use a private workforce. These are people usually in-house who have subject matter expertise. Or you can take advantage of third-party vendors who have different types of support levels and plans and maybe different types of expertise in what they can label as well. So 3 different types of, 3 different pools of labelers that you can choose from. Now, when you're dealing with large data sets here, the key is also to make this accurate as well. So ground truth has something kind of interesting here. Typically, if I'm in a room, this is where I'd ask the crowd, what type of dog do you see over here? But in this situation, let's say we have 4 different people who are the labelers in the situation. You have 3 of them say bulldog and 1 of them says Shar-Pei, right? In this case, with majority voting, it'll just be labeled bulldog, and this is incorrect. However, ground truth has uses an algorithm called expectation maximization to see the accuracy of these labelers as well and make sure that's also a component into this. So right now, even though we only had 1 labeler, that's Shar-Pei, because of expectation maximization algorithm that's using the background, this will be the answer for this particular use case. So it's definitely more accurate as well. And if you want to get a deeper understanding of that algorithm that we use over here for this, here's a link for that paper. It's pretty interesting. I recommend checking that out. Now, I spoke about price as well, right? And again, when you're labeling large sets of data to solve those machine learning problems, this is something that can get pretty costly. To help this, we have active learning and auto labeling set up for you to take advantage of as well, right? So looking at the left-hand side of this slide, you see this data set of animals that can be labeled, right? Drawing bounding boxes for. You choose one of those 3 different pools of labelers and you go ahead and start getting that data set labeled, which is great. But this again is a costly option. You can also set up active learning. So with active learning, in the background, it's constantly creating a model based on this data, right? So after 1,000 or more pieces of input, it'll go ahead and create a computer vision model over here. And then it'll start sending this data set to this model to get labeled, right? And in the beginning, you're gonna see this is low accuracy. So based on the accuracy level that you set, you can go ahead and send this back to the labelers and have it keep going through this process until the computer vision model that's in the background gets to a certain enough phrase where you're happy with the output, and then it'll start just using that for the labels instead of the labelers, and this ends up saving cost as well. So that's ground truth. Now, when you move to the top layer of AI services here at AWS, you see a bunch of these really interesting services here. You see vision, speech, text, and so on. While there's a lot of things here, I'm really passionate about that computer vision side of things, so I'll showcase some of that. But again, there is a lot of really interesting and cool services here that we've created here internally at Amazon or at AWS, and we've opened up to the public. So I really recommend checking that out. With recognition, it just makes it so easy to do computer vision and get really amazing high quality results based on that. It's also pretty interesting and simple to use. If you're a Python developer like myself, very simple to integrate that into your application as well. And then last thing over here, I wanted to showcase a use case that I thought was pretty compelling. The NFL wanted a solution to provide real-time statistics, and they were collecting a lot of data, quite a bit of data every week, right? So 3 terabytes of data, over 1,500 hours of play, and they didn't have any data science expertise or a team for this. So they approached our ML Solutions Lab and then worked with us, and they live streamed a lot of this data to AWS by putting RFID tags on the player and the ball in the game. And then from there, we started processing that data, and we built models on SageMaker to make predictions in real time. So this provides over 20 stats to the NFL, and announcers get to use that as well. One of the interesting ones over here is the probability of pass completion as well. Takes a look at a lot of that data, takes a look where all the players are, where the ball is, and it gives you stats on what's the probability that this pass will be completed. So some interesting use cases here with AWS. So if you have any questions on any of this, again, this is a topic that's near and dear to my heart. Feel free to either email me, kbatra@amazon.com, or you can reach out to me on Twitter or follow me on Twitter at Kunal732.